Hello there. This is your optional video that goes over the sheets on the Introduction to Right Triangle Trigonometry. You only need to watch this video if you did not understand fully the sheets number 1, 2, and 3 of this unit. So here we go. The first thing you were asked to do was to draw some triangle that is not the same size as this one that had these three angles. So this is where the right angle is, right here. And you can see right there that this is a 30-degree angle, which makes that being a 60-degree angle. So I'm going to get rid of that now. The next thing we had to do was to measure the lengths of the three sides. So the length of AB is 12 centimeters. The length of BC is 6 centimeters. And the length of AC is about 12 or 10.4 centimeters. So next we were asked which side is the hypotenuse. So what we're going to do is I'm just going to move these rulers. The hypotenuse is always the longest side, and it's also always the side that is opposite the right angle. So that's the hypotenuse, which we will label with an H, so that is AB. Which side is opposite the 30-degree angle? The 30-degree angle was right here. So the side opposite that is side BC. And the side adjacent to the 30 degrees, well, it looks like there's two sides adjacent. Adjacent means beside, or, in this case touching. There are two sides that are adjacent, this side and this side, but this side is already the hypotenuse. So this is the side right here that we would call the adjacent side. So that would be AC. You were then asked to calculate these three ratios and round to 3 decimal places. So I'm going to press pause and do those calculations. So just hang on a minute. Alright, so here's the 3 calculations that I got when I did this part of the activity. And you wrote your name and your 3 ratios on the board. These 3 ratios are the beginnings of what we're going to do with trigonometry. So I take out your calculator and make sure it's in degree mode. So at the top of the screen there should be a D or a DEG. If there's an R or a G instead, then you have to change your mode of your calculator into degrees. If you're not sure how to do that, look for the button on your calculator that says DRG. Sometimes it's hidden, sometimes it might be in the setup part of your calculator or the mode part of your calculator, but find where it says DRG and you would press that button until you get to a D. If you still can't find it and your calculator does not have a D at the top of the screen, then you'll have to ask your teacher tomorrow in class. So what I want you to do is to type in sine 30. If you get an error, or if you get something that does not say 0.5, then what you might have to do is type 30 sine into your calculator. If you have a display calculator, which means the calculator display shows you exactly what you're typing, and including the multiplication buttons and things like that, then that's a display calculator, and you would type in sine 30 equals. If you have a non-display calculator, that means it shows the numbers but it doesn't show the operations. So you would type in 30, but if you press the sine button, it doesn't actually say sine on the display screen. So try pressing sine 30 equals or 30 sine. Which one of those gives you 0.5? And that would be sine 30. So sine 30 is equal to 0.5. The full word is sine. It's just abbreviated as SIN. And sine is the ratio of the opposite side to the hypotenuse side. So if the angle was something different, say 50, sine 50, it would have a different ratio. The ratio wouldn't be 0.5, or the scale factor wouldn't be 0.5. The cosine, abbreviated as cos of 30, in your calculator, if you typed cos 30 or 30 cos, you get 0.866. That means the ratio of the adjacent side to the hypotenuse side is 0.866. And the tangent is abbreviated as tan, and that's the ratio of the opposite to the of the adjacent, and in a 30-degree angle, that is 0.577. And for any triangle that has 30 degrees and 60 degrees, they will always have the same ratios because everyone's triangles will be similar to each other. Because if you're dealing with a 30-degree angle and it's a right angle triangle, the other angle has to be 60. You've got similar triangles, so no matter how big the triangle is, if you have a 30-degree angle in your right triangle, these would be the ratios of these sides. So let me show you how this works in the different page. We're going to use the 30, 60, 90 example. Remember that this works only on a 30, 60, 90 triangle, no matter how big the triangle is, because they're similar. The ratios 0.5, 0.866, and 0.577 are always the same. If it's at different angles, these three ratios would be different. So what we're going to do is label the three sides with an O, an A, and an H. So here is the angle. So that is the opposite side. The side that's opposite the right angle is the hypotenuse. And the side touching the 30-degree angle that is not the hypotenuse is the adjacent side. So if sine 30 is equal to opposite over hypotenuse, that means that since the ratio is equal to 0.5, it means the opposite side is 50% of the size of the hypotenuse. So if the hypotenuse is 10, the opposite side would have to be 5, because 50% of 10 is equal to 5. Likewise, for the cosine ratio, cosine of 30 is equal to 0.866. That means the adjacent side is 0.866% as big as the hypotenuse. So it's 0.866 times 10, which is 8.66. And that's the way trig works. In the next video, you'll learn a more eloquent way of working this out, which is a little more structured. So hopefully that will become clearer if you're still unsure. We're going to try another example with a triangle that is not 30, 60, 90. So which side is the hypotenuse? It's the side opposite the right angle. So the hypotenuse is equal to JK. Which side is opposite to angle K? Here's angle K, so the opposite side is JL. And the side adjacent to K is the side touching K, which is not the hypotenuse, so that is KL. So we measured the three sides. Once again, we're going to find the ratios. So sine K is equal to the opposite side over the hypotenuse, which is 3/5. which is 0.6. So that means in this triangle, the opposite side is 60% as big as the hypotenuse. Cos k is equal to the adjacent over the hypotenuse. So that is 4/5. So that is 0.8. So in this triangle, the adjacent side is 80% as big as the hypotenuse. And lastly, tan is opposite over adjacent. So that is 3/4, which is 0.75. So that means that the opposite side is 75% as big as the adjacent side. So that's the beginnings of the right triangle trigonometry. This next page just goes over the terminology that we talked about. When dealing with right angled triangles, we often use the Greek letter theta, which is a 0 with an extra loop, to represent the measure of unknown angles. The hypotenuse is always the longest side across from the right angle. The other two sides are named either opposite or adjacent depending on the location of theta. So there's the hypotenuse. There's the opposite side. But there's the opposite side if the angle's up here. And here's the adjacent side, but in this triangle the adjacent side is over there. And the three formulas you need to know for this unit are sine equals opposite over hypotenuse, cos equals the ratio of the adjacent to the hypotenuse, and tan is the ratio of the opposite to the adjacent. You will not be given those formulas on a test, but what you would be given is this word SOHCAHTOA. Say that word with me, SOHCAHTOA. So it's an abbreviation, or an acronym, which stands for sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and tan is equal to opposite or adjacent. So remember, these formulas only work in a right angled triangle, and you have to have a scientific calculator that has the sine, cos, and tan buttons on them, and you have to be working in degree mode. So hopefully this explained those sheets a little bit better than you might have understood them before, and now what you're going to do is watch the next video, which is solving for sines using SOHCAHTOA. Thank you. Goodbye.